Right out of the gate, it's crucial to know that everything we're looking at today comes straight out of the official National Society of Professional Surveyors Level 1 Sample Examination Booklet, released in January 2024. This isn't just random theory. This represents the actual complexity, the exact phrasing, and the real makeup of the questions you're inevitably going to face. By using the official source material, we're basically calibrating your brain to the exact frequency of the test writers.
Now, the number 15 is a huge deal here. Out of a massive 200-question, 4-hour exam, exactly 15 questions are dedicated to survey types and history. Mastering these specific questions is a seriously strategic move. Think about it. Unlike those brutal trigonometric calculations that just eat up the clock, these historical and definitional questions are essentially free points if you've got them memorized. Snagging these 15 points quickly and confidently means you're buying yourself incredibly valuable time later on for the heavy math.
Question 1, historical measurements. Let's jump into our first case study. All right, here's the question. Which of the following is not a historical unit of measurement? Take a second. What's your guess? Notice the word not there. Test writers love using negative framing to check your deep comprehension rather than just surface-level recall. They want to see if you can confidently spot the difference between an actual measurement unit and other historical concepts that just sound kind of similar. So here are your 4 choices: Vara, Gunter's chain, Banneker, and engineer's chain. Let's use the process of elimination. If you've been studying up on your history, a couple of these should instantly jump out at you as literal, physical tools. A Gunter's chain is a very specific historical device, exactly 66 feet long with 100 links. An engineer's chain is super similar, but it's exactly 100 feet long with 100 1-foot links. Since both of these are standard physical units of measurement, boom, we can instantly cross out options 2 and 4. What about option 1, the vara? Well, the vara is actually a legitimate historical unit of length. It's roughly equal to a yard, and it was used heavily in early Spanish and Portuguese land surveys. If you're ever out surveying property lines in places like Texas, California, or the American Southwest, you're absolutely going to run into the vara in historical land grants and deeds. It's a foundational measurement out there. So confirm it as a unit of length and eliminate option 1. That leaves us with option 3, Banneker, or Benjamin Banneker. He wasn't a unit of measurement at all. He was a highly famous historical astronomer, mathematician, and surveyor. You might actually know him for his crucial role in assisting Andrew Ellicott with the original survey of the borders of the District of Columbia. Since he was a literal person, option 3 is our odd one out. Recognizing the difference between historical figures and historical tools is exactly the kind of nuance you need for the CST exam. Moving right along to question 2, mining terminology. Ask yourself this one. In a mining survey, you were asked to survey a new adit. What is an adit? Consider what kind of subsurface structures you might actually encounter out on the job. Surveying isn't just walking across flat fields with a total station. You frequently find yourself in highly specialized environments, like deep underground mining operations. And down there in confined spaces where GPS is completely useless and 3D mapping is king, the professional terminology shifts dramatically. Looking at our 4 highly specific geological options, we need the exact technical definition of an adit. Now, these all sound like totally reasonable mining terms, right? That's exactly why vocabulary precision is so vital. Let's knock out the wrong ones first. Option 3, an excavation at the bottom of a shaft, is usually called a sump if it's collecting water, or a shaft station. Option 4, the angle at which a bed is inclined, is known technically in geological surveying as the dip. So we're down to options 1 and 2. Let's check the official definition. An adit is a horizontal or nearly horizontal passage driven from the surface for the working or dewatering of a mine. See how that specific defining characteristic completely separates it from a vertical shaft that drops straight down, or a standard main haulage road that might be entirely underground? Its defining features are its origin point, entering horizontally right from the surface, and its function, which is usually drainage, ventilation, or transporting materials. Keeping that definition firmly in mind, the answer is clearly option 1, a tunnel driven for mine drainage, ventilation, or transportation. Nailing this means you really understand that mine structures are defined just as heavily by their function and how they orient to the surface as they are by the fact that they're, well, holes in the ground. Question 3, hydrographic datums. Time to emerge from the underground mine and head out onto the open water. Here is the question. Hydrographic surveys must be referenced to which of the following datum or datums?
Let's think about this practically. When you're out surveying bodies of water, how exactly do you reference your measurements to be Earth? You're not dealing with a static piece of dirt anymore. You have to account for a dynamic body of water, tidal fluctuations, moving vessels, and the invisible land beneath it all. We've got 4 options: horizontal only, horizontal and vertical only, or tidal. Now, option 4, tidal, is a really clever distractor. Because you're on the water, a novice might instinctively just jump at the word tidal. But while a tidal datum, like mean lower low water, is a specific type of vertical reference used in hydrographics, it's just not the full scope of the question. A tidal datum all by itself isn't enough to perform a full hydrographic survey. To really get this, we need to think about spatial referencing as a whole. Horizontal datums give you exact positions on the Earth's surface, your X and Y coordinates, basically your latitude and longitude. Vertical datums are used for measuring land elevations and water depths, your Z coordinate. A hydrographic survey is totally unique because you have to plot exactly where your boat is on the water's surface using GPS, while seamlessly and simultaneously pinging the depth of the floor beneath you using sonar or an echo sounder. Because of that, the correct answer absolutely has to be option 2. Mapping underwater topography inherently requires both horizontal and vertical reference points. Think of it as a complete spatial package. If your echo sounder reads a depth of exactly 40 feet, that data point is utterly useless if you don't know the exact horizontal X and Y coordinate where the boat was located at that exact second. You have to know where you are horizontally to know where that vertical depth reading belongs on the final map. Let's wrap this up. Essential test day takeaways. Reviewing the key concepts. Taking a step back, the sheer variety of knowledge you need as a modern Level 1 survey technician is crystal clear. We've seen how historical mapping means knowing physical tools from the famous people who used them. Mining surveys require exact, function-based structural terminology in 3D space, and hydrographics demand a comprehensive understanding of multi-dimensional datums. To pass this test, you've really got to be a dedicated jack of all trades across multiple diverse environments. Oh, and remember, this incredibly practical piece of advice from the source material. This is an open book test. Bringing your essential reference guides is a total game changer for your success. You'll want a fundamental surveying text with unit conversion charts, a first aid and safety manual, and a comprehensive book on surveying definitions. Honestly, if you had that definitions book sitting on your desk on test day, you could have looked up ADIT and VARA instantly, backing those points and saving all your mental energy for the complex math portions. You've built a rock-solid foundation with these 3 case studies today, analyzing exactly how the NSPS phrases their questions and tests your practical knowledge. You've mastered the first 3, but with 197 questions left standing between you and your certification, ask yourself, is your foundation built on simple, fragile memorization, or is it built on a true, multi-dimensional understanding of the surveying field? Keep digging deeply into those definitions, keep visualizing those environments, and you will undoubtedly crush this exam.